Okay, so we were asked to fill in these values, which we have them up on the board, but just kind of explaining one more time where they came from. Thinking of at 0, this point is 1, 0, and so cotangent is always going to be x over y. 1 over 0 is undefined. If I want to draw a 45-degree angle, 45 goes 1, 1, radical 2. So the cotangent, again, is x over y, so that's going to be 1. Pi over 2, I have to go back to the unit circle. This point's 0, 1. Cotangent is x over y, so that's 0. At 3 pi over 4, that's a 45-degree reference over here. So this is negative 1 and 1, so x over y is negative 1. At pi, I go back to the unit circle. X over y is undefined. At 5 pi over 4, that's going to be down here with a 45-degree reference, negative 1, 1, radical 2. X over y is negative 1. 3 pi over 2, you get the idea. This should be 0. This ends up being positive 1, and this ends up being undefined. So our goal for today is to be able to graph these, okay? So I'm now going to, I don't need that, I need this. So you might want to do this on right here. You've got a nice little axis down here on page 262 in your student journal. So looking at these table of values, it's the same thing they did up here, but we just did them in our warm-ups. So at 0, this is, and we're graphing, instead of tangent, we're going to graph y equals cotangent first. Change this to cotangent. Okay, so looking at cotangent then. So at 0, we're undefined, so we have a vertical asymptote. At pi over 4, right here, we're at 1. At pi over 2, we're at 0. 3 pi over 4, we're at negative 1. At pi, we're undefined. At 5 pi over 4, we're at, this should have been a positive 1 here. At 5 pi over 4, we're at positive 1. 3 pi over 2, we're at 0. This should be negative 1. 7 pi over 4, we're at negative 1. And then we have another vertical asymptote. Now, to get a feel for what this looks like, let's graph this on our graphing calculator. So get out your graphing calculator. We're trying to graph cotangent. So you're going to go to y equals, and you're going to put in 1 divided by tan x. That's going to allow us to graph cotangent. So I'm now going to do a zoom trig, zoom 7. And this is the way the cotangent graph looks. We're only starting it at 0, so we're only seeing from 0 to pi, from pi to 2 pi, and so this is the way the cotangent function is graphed. Now, the special points we have to know. We have to know that the vertical asymptote for cotangent, the first one is always going to be at x equals 0, as long as we don't have a shift left or right, which we're not going to deal with this year. So vertical asymptote, the first one is at x equals 0. The second thing we do is we find the period. The period on these is going to be pi divided by b. Well, in this case, we have b is just 1, so the period is pi. See how that's when it starts repeating? After we get to pi, then it starts repeating again. So that's why the period is normally pi. The third thing we do is we do this 0 plus or minus the period, and that's going to find, so to find other vertical asymptotes. And then we know in the middle of the vertical asymptotes is 0. So in the middle of the two vertical asymptotes, it's always 0. And then we also know that the points here have to be 1 and negative 1. Other points are 1 and negative 1. And the last thing is, we know that this function, see how it's going down. It's always going to go down. So the first vertical asymptote is at x equals 0. We find the period by doing pi over b. We do 0 plus or minus the period to find other asymptotes, vertical asymptotes. The middle of the vertical asymptotes, that value is going to be 0. Our other points are 1 and -1, and it has to be going down. All right? Questions? Okay, let's go over then and look at one that we want to graph. So flip over to page 266. We're going to graph number 2 because it's a cotangent one. All right, so on number 2, the first thing we're going to look at is a vertical asymptote. We know the first one is at x equals 0. How can you remember that the first one's at x equals 0? I always remember it because cotangent has this O right here. I don't know, that just helps me to remember that the first one's at x equals 0. Because for tangent, it's not going to be at 0. But tangent also doesn't have an O in it. So the first one's at x equals 0. Now we're going to find the period. So the period is going to be pi divided by 1/2. What is pi divided by 1/2? 2 pi. So if I want to find more vertical asymptotes for this, I know they're going to be at ... x equals -2 pi, comma, x equals 0, comma, x equals 2 pi, comma, ... Goes on forever in that pattern. So I'm going to go ahead and make my axes. I know that I have a vertical asymptote at 0, so I'm going to graph that. I know I'm going to have one at 2 pi, so I'm going to call this pi over 2, 3 pi over 2. I'll call this 2 pi. And then this is -2 pi. That's pi over 2, pi, 3 pi over 2, -2 pi. So there are my vertical asymptotes. What happens halfway in between the vertical asymptotes? What value do we have? 0. So I know it has to be 0 here. I know it has to be 0 here. I know the other points are always going to be 1 and -1. However, what does this do to our points? Stretches it, doesn't it, by 2. So instead of this next point being at 1, where's it going to be? Just at 2. It's just a vertical, it's a multiplier. So it's going to be at 2 here and at -2 here. And here it's going to be at 2, and here it's going to be at -2. And so we know that this function is going to go like this. Has to go down. And all I'm going to ask you to write is the vertical asymptotes, and then graph it. There really aren't any key points on this, so that's why I'm going to actually need you to graph it. If I wanted to check this, though, I could by doing 2 divided by tangent of 1/2 x. Zoom 7. Oops. I have one too many parentheses. And here's the way it looks. Okay, makes sense? This is from 0 to 2 pi and 0 to -2 pi. It looks just like ours. All right, let's do the other cotangent, number 4. Okay, so the first thing, we're going to find our first vertical asymptote. The first one is at x equals 0. We're going to find the period. What's the period going to be here? Pi over 3. How did you get that? Right, so it's going to be pi over 3. So now I'm going to write out some of my vertical asymptotes. I know they're going to be ... x equals -pi over 3, x equals 0, x equals +pi over 3, ... Okay, so let's go ahead and graph. So at negative pi over 3, I'm just going to make that go, we'll do this. There's negative pi over 3. There's 0. Positive pi over 3. 2 pi over 3. Keep going on and on. So we know that halfway in between these has to be 0, in between all the asymptotes. We know that normally they're going to be halfway in between here is going to be 1, but what's it going to be now? Not 1, but our multiplier is now, Charlie?
I have a question.
Yeah.
Is there a vertical asymptote x equals 0?
Yes.
Every time?
Yes. For cotangent, yes. Okay, so then halfway in between here would normally be 1, but what's it going to be now, you guys? Just whatever this amplitude, vertical, yeah, so it's going to be a vertical shrink of 1/2. So it used to be at 1, but now it's only a half there, negative a half there. So now it's going to go like this. It's a vertical shrink. I know it has to go down. Okay, and that's the way it's going to look. All right, now we're going to do tangent. Tangent is much tougher. Yeah, Scotty?
The two, like the one that's the two dots in the middle.
Mm-hmm.
How do you put these on my line?
These two?
Yeah.
Okay, so normally they would be up, in between these two would be up 1 because of what we did earlier and down 1. But this is always a multiplier. So this is going to mean that instead of it being 1, it's going to be only a half. So like on this one, it would have normally been 1, but now it's going to be 2. Yeah. Michaela?
What are you counting by on the x-axis?
I'm actually going by, if this is pi over 3, this would be, what, pi over 6, half of that? So I'm going by pi over 6 everywhere. Any other questions? All right, so now let's do tangent. Like I said, tangent is a little bit tougher. We've got some room here on page 263. All right, so if we're doing y equals tangent x, just to kind of get a feel for what this looks like, I'm going to make a table of values. Think of the unit circle and then some triangles as well. And on this case, we're going to go from negative pi over 2 to positive pi over 2, just to kind of see what happens there. So I'm going to put my points on my unit circle. So right here, this point is 0, negative 1. This point is 1, 0. This point is 0, 1. This point's negative 1, 0. I'm going to go ahead and put in the point here. This point right here at negative pi over 4 is going to be radical 2 over 2, comma, negative radical 2 over 2. This point right here is going to be positive radical 2 over 2, comma, positive radical 2 over 2. So at negative pi over 2 right here, what's the tangent going to be? What's y over x going to be right here? Undefined. And negative pi over 4, if I do y over x, what's anything divided by itself? So in this case, it's going to be negative 1. At 0, y over x, what is it? At pi over 4, y over x, 1. And right here, 1 over 0 is undefined. So graphing just the regular tangent x, here's what happens. The period is still pi. The normal period is still pi. But how did we find these vertical asymptotes? We don't start at 0. can you see how these vertical asymptotes are, the first vertical asymptote is going to be the period divided by 2. See how this first vertical asymptote is at pi over 2, and then I could subtract pi, or I could add pi. So this is something a little different. The period is going to be pi normally. The first vertical asymptote, I take that period and divide it by 2. So it's at pi over 2. I'm going to make this go by pi over 4. So pi over 2, negative pi over 2. Here's the pattern. In between negative pi over 2 and pi over 2, we're going to be at 0. In between these two, we're going to be at a y value of negative 1. In between these two, at pi over 4, I'm going to be at positive 1. So what's going to happen to this graph is it's not going to be going down like cotangent did. Let's go to our graphing calculator. Just type in tangent of x and do a zoom trig. So tangent of x is not going down from left to right. What's it doing? It's going up. Okay, so here's what it's going to look like. And that would continue in that pattern. Okay, so there's tangent. So what's the difference between tangent and cotangent? Cotangent goes what? Down. Tangent goes up. That's one big difference. Okay, let's write out some other things here. So to graph tangent, to graph y equals a tan of bx, the first thing you want to do is find the period. And that's going to be pi divided by b. The second thing you're going to do is you're going to find the first vertical asymptote. That's going to be at the period divided by 2. The third thing you're going to do is add or subtract the period to find other asymptotes. Add or subtract the period to find other asymptotes. And then the fourth thing is you have to remember that these points go negative 1, 0, and 1 are those points in between there. Maybe one more thing to write down is that this one goes up from left to right. So see how these points, negative 1, 0, 1, go up instead of down like the other ones did? Okay. And then we know that these points, what do they get multiplied by? What is it, guys? These get multiplied by what? Multiply those by A as needed. Yes, Scotty? Huh? 3 says add, subtract the period to find other asymptotes. Do you have the rest of it? Okay. All right, let's go over here now and do a couple of tangent graphs. Okay, so we have a tangent graph on 1 and on 2. Okay, so looking at number 1, first thing we're going to do is find the period. Dominic, what's the period going to be? Yep, pi over 2, or 1/2 pi. Okay, so that's the period. Now to find my first vertical asymptote, what do I do to that period? Do you remember, everyone? divided by 2. Okay, so what's half of pi over 2? Pi over 4. Okay, so my first vertical asymptote is x equals pi over 4. Then to find another one, I just add on the period. So pi over 4 plus pi over 2, what's a fourth plus a half? 3 pi over 4, right? Okay, so we're going to put these in here. So my first vertical asymptote is at pi over 4. I'll make that right here. My next one is at 3 pi over 4 right here. I can go backwards pi over 2. Where's it going to be if I go backwards pi over 2? At what? Negative pi over 4, good. Which is right here. I'll just go back another one, too. All right, so now I know in the middle of these, I've got to have right there. In the middle of these, we've got to be right there. In the middle of these, we've got to be right there. Now, what about for tangent? Does it go up or down for tangent? It goes up, doesn't it? Cotangent with that O, cotangent goes down. So then tangent has to go up. So I know that in between here and here, we have to be at -1. In between here and here, we're at +1. And so it has to go up. In between here and here, we have to be at -1. In between here and here, we're at +1. We have to go up. This is -1, +1, have to go up. Okay, questions on that? All right, let's do this one now, number 4. Okay, so on number 4, first thing we have to find is the period. So we have to do pi divided by what? Natalia, what do I divide by? Pi divided by?
Wait. So it would be divided by 1/4. Pi over 4, yeah.
Pi divided by pi over 4. What's that going to give you then?
4.
It's just 4. So the period is just going to be equal to 4. So now I'm going to find a vertical asymptote. I'm going to take that and divide it by 2. And what do we get, everyone? 2. So our first vertical asymptote is at x equals 2. Let's go ahead and make our axes. So my first vertical asymptote is at x equals 2. To find another one, I can add on my period to get x equals 6, or I could subtract that period and get x equals -2. So I'm going to have one here at -2. I'm going to have one here. It's going to look like that. All right, so then we know halfway in between here, we're going to be at 0. Halfway in between here, we would normally be, it has to be going up, so we would have normally been at -1, but now look at it. This is our multiplier. That's our vertical shrink of 1/4. So right here, instead of being at -1, I'm going to have to be at -1/4, right about there. Halfway in between here, I would have normally been at 1, but now I'm at +1/4. And so it's going to go like this. Halfway in between here, we're at 0. Halfway in between here, we're at -1/4, +1/4. Halfway in between here, we're at 0, -1/4, +1/4. Okay? Questions on that? All right, so I want us to take a break because we have to do secant and cosecant, and they're actually easier